All right, good afternoon. We're going to talk about classifying polynomials. So let's first off, we need to know what a polynomial is. So what is a polynomial? A polynomial is an expression made of many terms called monomials. Monomials are numbers, variables, products, or product of numbers and variables with whole exponents. Okay, the standard form of a polynomial is we write, or has two requirements. All like terms are combined, and it's written from the biggest to the smallest exponent. So when our polynomial is in standard form, we can then find the degree of the polynomial and its leading coefficient. So the degree is the largest exponent. The leading coefficient of the polynomial is the coefficient of the first term when the polynomial is in standard form. So basically, this is a term with our largest exponent. So looking here, I've got this example here. I've got 5x plus 9 minus 2x squared. So first thing I want to do is I want to find what is my largest exponent. So this each of these is what we'd call a term. Notice they're separated by an addition or a subtraction sign. Okay, so those are terms. So first thing I want to do is I want to write this in standard form. And I want to write it with the term with the largest exponent, which in this case is the 2x squared. So my first number would be 2, or my first term would be 2x squared. Then I'm going to look, well, I have a 5x. Okay. So that would be my next largest exponent, variable with an exponent. And then finally, I have my constant. So this polynomial would be written in as negative 2x squared plus 5x plus 9. Now we want to, how many terms did I have? Well, how many times is it separated, right? I have one, oops, let me highlight these. I have 1, 2, 3. So I have 3 terms in this polynomial. The degree, remember that is my largest exponent. So my largest exponent here is 2. So my degree is 2. And the leading coefficient in this case would be the coefficient of the term with the largest exponent, so negative 2. All right, let's look at another one. Okay, I'm going to erase this here just to... So I need to find my term with the largest exponent first to write this in standard form. So I'm going to highlight each term in a different color. So here's a term. So what is the one with the largest exponent? Well, my dark green one here, right? My negative 8a to the 5th. Write that a little better. Is my term with the largest exponent. My next one would be the a squared. So we're going to do minus 12a squared. Then 10a, so plus 10a. And finally our constant, minus 7. So how many terms did I have? Well, how many different colors did I use? Okay, I had 4. So this has 4 terms. My degree, what is the largest exponent we have? 5. And our leading coefficient, the number with our term, so the coefficient of our largest exponent term was negative 8. All right, let's look at this last one really quick. Now, first thing I want to look at, do I have any like terms? Because we've got a lot going on here, right? So first thing I've got x squared and x squared. So 6x plus 1x squared. So 6x squared plus 1x squared gives me 7x squared. I have 2 constants that I can add together, which 5 plus a negative 4, or 5 minus 4, give me a positive 1. And then finally, I have 6x plus 2x, which gives me 8x. Now, this is not in standard form yet. I need to do a little rearranging. Okay, my largest exponent would be x squared. So I do have 7x squared in its right spot. 8x would come next, plus 1, with my constant at the end. If we have a number without a variable, it's always going to be the last thing we write. So from here, how many terms do I have? I have 1, 2, and 3. So I have 3 terms here. What is my degree? What's the largest exponent? 2. And our leading coefficient on this one was 7. All right, so that's just writing it in standard form and picking out how many terms we have and our degree, which the number of terms and the degree will play a big part in our next section. So once a polynomials are in standard form, we can classify them 2 ways. By using the degree and by the number of terms we have. All right, so remember, classifying polynomials by degree. Remember, the degree of the polynomial is its largest exponent. So if my largest exponent is 0, well, that's just a constant. This is just any number we have, like 3, 4, 5. Okay, if all I have is a number, it's called a constant. This is something we've come across already. If I have a degree of 1, that is linear. So like 2x plus 1. My largest exponent there is 1. Okay. If my degree is 2, it's a quadratic. So like negative 2x squared plus 3. A degree of 3 is a cubic. Degree of 4 is a quartic. Oops. Okay. Degree 5 is a quintic. And degree 6, well, let's just say 6th degree or other. So if anything above 5, we just say 6th degree, 7th degree, 8th degree, okay? Just depending on what our largest exponent is on that one. Now, our other classification is by the number of terms. This is our second name, okay? And remember, the terms are separated by the addition, subtraction. So we're always going to have at least one term. This is called a monomial. An example of that is like 3x, 2x squared, 1. These are monomials. If I have a constant, it's almost always going to be a constant monomial. And we'll talk about that here in a minute. Okay, if it has 2 terms, that's a binomial. 3 terms, a trinomial. And if we have more than 3, it's just going to be a polynomial. So, classifying by number of terms is fairly simple. We've only got 4 of them. So let's look at some examples here. If I've got just the number 8, well, that's a constant, right? Because we have no variable. And I have 1 term, so it's a monomial. Now looking at number 10 here, what's my largest exponent? Okay. That's a degree 4. So it's a quartic. And how many terms do I have? I have 3 terms. So it's a quartic trinomial. Looking at 11, what's my largest term here? 3. And how many terms I have is 1, 2, 3, 4. So it's a cubic, since it's a degree 3, polynomial. Now, if we look at 13 and 14, they're not as simplified as we can get, right? So I'm going to combine my like terms here. So 6x minus 4x, right? are my like terms in 13. So that gives me 2x minus 2x squared plus 5. I'm going to go ahead and put this in standard form. So negative 2x squared plus 2x plus 5. Sorry guys, I'm going to rewrite this just to make it easier to read. So, since my largest degree here is 2, it's a quadratic, and we have 3 terms, trinomial. Okay, on 14, combine my like terms.